RHS Pre-Calculus presents Kite Shadowography, explaining and applying the law of science.
Once upon a time, you were flying your kite with your invisible imaginary friend Michelle. While you were standing on top of a sand dune, Michelle said, "I bet you can't figure out how long your kite's shadow is." You immediately accept the challenge and notice a sign that tells you that the sand dune's angle of elevation is 10 degrees. You ask for a hint from Michelle, who tells you that the sun has an angle of elevation of 42 degrees today. You also notice that the kite is about 10 feet above the sand dune. Using that information, you begin to ponder your options of how to solve for the length of the shadow.
Why not use the law of sines? The law of sines is a trigonometric formula that can be used to find missing side lengths and angles of oblique triangles. It states that the sine of angle A over side A is equal to the sine of angle B over side B is equal to the sine of angle C over side C.
Using the information given and keeping the law of sines in mind, you start to draw a diagram to aid you in your quest. You begin by drawing the sand dunes with you at the top, taking note of the 10-degree angle of elevation. You then add the kite, labeling its height as 10 feet. From there you add the sun to the diagram, placing it at a 42-degree angle from the horizon. Mark the length of the shadow as x, and you are ready to start calculating.
Before you can use the law of sines, you have to make a quick calculation to find the topmost angle. You can do this easily using the fact that every triangle has 3 angles that add up to 180 degrees. You already know that the bottom left angle, the angle of elevation of the sun, is 42 degrees, and you know that the bottom right angle of this particular triangle is 90 degrees. You make short work of this calculation, finding that the angle in question is 48 degrees. You now move on to using the law of sines and completing Michelle's challenge.
To find the missing side length, you set up the law of sines equation so that sine of 32 degrees, not 42, since we are now working with a different triangle, divided by 10 is equal to the sine of 48 degrees divided by x. To save time, you cross-multiply and divide. This means that instead of taking more steps, you simply multiply the sine of 48 degrees by 10, and then divide the resulting sum by the sine of 32 degrees. This gives you a value for x, showing that the kite's shadow to be 14 feet.
Michelle is extremely impressed that you were able to win the bet, and you owe it all to the law of sines.